Okay, simultaneous equations for quadratic equations. If you recall, for plane straight line simultaneous equations, we will have two straight lines such as y equal to 2x and y equal to half x plus 2. We can use the method of substitution, in which case we just assume the y here is the same y here. So which means it's also 2x. So 2x equals to half x plus 2. In essence, we just substitute first y into the second equation here. So now, once we have this, we have essentially eliminated the one of the pronumerals, which is y, and we only have x left. And with this part, we can just solve it as per usual. So we subtract half x from both sides, and we end up with 3 over 2x equals to here 2. And once again we divide 3 over 2 by both sides, and we end up with x equals to 4 over 3. So this is the x value. What it means is, if we plot the two lines, y over 2x will look something like this, and the second one will look like something like this. And 4 over 3, it means the x value of the intercept here, where the two lines intersect, is 4 over 3. And then we use this x value substituting equation to find the y value here. So when x equals to 4 over 3, y equals to 2 times 4 over 3, which gives us 8 over 3. So that's the y value of the intercept. Now, the similar process can also be applied to quadratic equations. Of course, in this case, we'll only look at quadratic equations and the straight lines. But the process really works for many other kinds of curves too. So let's have the simplest examples of a straight line and a parabola. Y equals to x, which looks something like this, and y equals to x squared, which looks like this. So just by looking at the diagram here, we can see that there are two intercepts. The intercept here and here. And to find where these 2 points are, once again we will resort to the method of substitution. We just assume that this y is the same y here. So we substitute this value here. We end up with x equals to x squared. And once again, we solve it like a normal equation. We take x from both sides, we end up with 0 equals to x squared minus x. And this is just another quadratic equation we have to solve. We factorize it first. So x times x minus 1. In this case, either x equals to 0 or x minus 1 equals to 0, in which case x equals to 1. So we can safely say that this point is 0 here and 1 here. Now, to find the corresponding y values for each of the x value, we substitute x values back into the original equation. So should we use the first one? So when x equals to 0, y equals to 0, and when x equals to 1, y equals to 1. So this is 1 here, and obviously this is 0 here. Now let's try something slightly more complicated. Y equals to x squared minus x minus 2. Y equal to x plus 6. So this is our parabola and this is our straight line. Once again, we simply assume that this y is the same y here. So we substitute this part into the y here, and we end up with x squared minus x minus 2 equals to y plus 6. And like in solving normal equations, we subtract x plus 6 from both sides, and we end up with x squared minus x minus 2 minus x minus 6 equals to 0. And you will have x squared minus x gives minus 2x minus 2 minus 6 gives minus 8 equals to 0. Another quadratic equation, so we solve it by factorization. We have x here with something and x here with something else. So these two numbers here, when you add them, they have to produce minus 2, and when you multiply them, they have to produce you minus 8. So the only two possible answers are negative 4 and positive 2. If you think about it, minus 2 times positive 2 gives you minus 8, and the minus 4 plus positive 2 gives you minus 2. So we end up with x minus 4 equals to 0 and x plus 2 equals to 0. In first case, x has to be 4, and in second case, x has to be negative 2. And once again, we substitute these x values back into original equation to find out the corresponding y values. So y equals to x plus 6, and when x equals to 4, y equals to 4 plus 6, which means y equals to 10. And when x equals to negative 2, y equals to negative 2 plus 6, so y is 4. What this means is that if we have our parabolas, a parabola and a straight line, apologies. So the parabola will look something like this. The straight line will look something like this. And the first intercept, x equals to negative 2 and y equals to 4, will be somewhere here. Will be here. And this point here, the second intercept, would be x equals to 4 and y equals to 10. So here are our two intercepts. Now let's have an example. Y equals to 2x minus 3 and y equals to x squared minus 3x plus 1. So once again, a straight line and a parabola. We just assume that this y is in fact the same y here, so we can simply substitute this part back into it, which means we end up with 2x minus 3 equals to x squared minus 3x plus 1. And like solving all normal equations, we subtract 2x minus 3 from both sides, and we end up with 0 equals to x squared minus 3x plus 1 minus 2x plus 3. So we end up with x squared minus 3x minus 2x gives us minus 5x plus 1 plus 3 gives us 4. And we can factorize this. So we have x with something and x with something else. Obviously, these two numbers, when we add them, they have to give you negative 5, and we multiply them, they have to give you 4. So these numbers can only be 1 and negative 4. And x minus 1 has to be 0, and x minus 4 has to be 0. Which means here x has to be 1, and here x has to be 4. Once again, we substitute these numbers back into the original equations to find out the corresponding y value. So when x equals to 1, y equals to 2 times 1 minus 3, which gives us 2 times 1 is 2, 2 minus 3 minus 1. And then when x equals to 4, y equals to 2 times 4 minus 3. So y equals 2 times 4 is 8, 8 minus 3 is 5. So the first intercept is at 1 minus 1, and the second one is at 4